images. It is related to the breast ultrasound images. Then we're going to talk about CIFAR-10 dataset and how we uploaded all our datasets to the virtual machine using SSH in browser. Then we will build, train, and test the convolutional neural network for the CIFAR-10 dataset. After that, we're going to compare the accuracy levels between the convolutional neural network for the main MNIST and CIFAR-10 datasets. Later on, we will try to improve the convolutional neural network performance by adding an extra layer, and we will see the results, and finally we will have a conclusion. In this project, we'll create a convolutional neural network that will be used to help us find patterns in the images dataset in order to recognize objects. TensorFlow will be used as the AI framework to build a neural network. The dataset CIFAR-10 will be used to develop the convolutional neural network. According to Krzyzewski, 2009, the CIFAR-10 dataset consists of 60,000 32 by 32 color images in 10 classes, with 6,000 images per class. There are 50,000 training images and 10,000 test images. The dataset is divided into 5 training batches and test batch, each with 10,000 images. The dataset contains images about airplanes, automobiles, birds, dog, frog, horse, sheep, and trucks. The first part of the project will be related to building, training, and testing the convolutional neural network for the CIFAR-10 dataset. Second, we'll compare the accuracy of the convolutional neural network for the CIFAR-10 dataset with the accuracy level for the MNIST dataset. The MNIST dataset contains 70,000 images of handwritten numbers from 0 to 9. Lastly, I will propose changes on the convolutional neural network in order to try to increase the accuracy level of it. A dataset of images. As we can see in this presentation, we have 3 images, and these are images used to recognize breast cancer. It is called breast ultrasound images for classification, detection, and segmentation. I've chosen a dataset of images for this part. The dataset is called breast ultrasound images for classification, detection, and segmentation. The dataset was retrieved from Kaggle. It consists of 780 PNG images of 500 by 500 pixels. The images were collected in 2018. The dataset includes breast ultrasound images among women in ages between 25 and 75 years old. The images are classified into 3 categories, which are normal, benign, and malignant. The figure in the picture show all 3 classifications. According to the Center for Disease Control and Prevention, 2022, breast cancer is a disease in which cells in the breast grow out of control. Depending on which cells in the breast turn into cancer, there are 3 types of this cancer, which are invasive ductal carcinoma, where the cancer cells start from the center and then spread out and invade lobular carcinoma, where the cancer cells start from the sides and then move to the center. This is the dataset I have chosen, not for this project, but as a reference or as a way to learn more about datasets with images. Alright, now regarding the CIFAR-10 dataset, as we can see in the presentation, here we have the classes in the dataset as well as some random pictures, images for each one. As mentioned before, this dataset consists of 60,000 32 by 32 color images in 10 classes with 6,000 images per class. There are a total of 50,000 training images and 10,000 test images. We can see there that we have images of airplanes, automobiles, birds, cats, deer, dog, frog, horse, sheep, and truck. And in the pictures below, we can see that this dataset has been uploaded into the SSH using in browser in order to have it all available to work on Jupyter Notebook. Alright, in the first part of the project, we're gonna build, train, and test convolutional neural networks on the CIFAR10 dataset. Build, train, and test CNN on CIFAR10 dataset. The design of our convolutional neural network starts in the convolution layer 1. As we can see, the convolution shape will be 1 for the patch, 32 for the height, 32 for the width, and 32 for the depth. The patch represents a division of the entire dataset used when training the model. Height and width equal to 32 and depth is 32. The 2D dataset is 32 by 32. The input shape will be 32 by 32 by 3. The depth equals 3 in channel. It's 3 because images are colored. The output shape will be 32 by 32 by 32. Depth equals 32 out channels. The filter kernel window size will be 5 by 5. The filter shape is 55332. With the filter, we can obtain the features from the image. The stride equals 1 and the stride shape will be 1111. It represents the shape of the skip cell. The middle indexes are sized stride. It means 1 pixel for the height and 1 pixel for the width. Padding will be the same. This is going to be used to maintain the size of the feature. The activation function layer, it will be the output of the convolution layer. As part of the design, the RELU layer 1 is the output of the convolution layer 1. It contains no filter and the input and output shape, which will be 32 by 32 by 32. The pooling layer 1 is composed by the pooling method, which we're going to use max pooling, the filter kernel window size, which is going to be 2 by 2, and the filter and kernel window shape, which is going to be 1 by 2 by 2 by 1. Stride equals 2 and the stride shape is 1, 2, 2, 1. Padding we're keeping the same. The input channel is 32 inputs. The input shape will be 32 by 32 by 32 and the output channel is 32 outputs. The output shape will be 14 by 14 by 32. The convolution layer 2 is going to be designed as follows. The convolution shape will be 1 for the patch, 14, and 14 for the height and width, and then 64 for the depth. We have the same batch as the convolution layer 1. The height and depth are different in this layer. It's 14 now and the pixel is 64, meaning that we will extract more features from the input. The 2D data size is 14 by 14. The input shape is 14 by 14 by 32. The depth equals 1 in channel. The output shape will be 14 by 14 by 64. And the depth equals 32 out channels. The filter and kernel window size, it will be 5 by 5. The filter shape, it's 5, 5, 32, 64, 1 stride. The pattern will be the same and the activation function layer is RELU. The RELU layer 2 has no filter and the input shape will be 14 by 14 by 64. The output is going to be 14 by 14 by 64. The pooling layer 2 is composed by the filter and kernel window size 2 by 2, the filter and kernel window shape 1, 2, 2, 1, two strides, and the stride shape will be 1, 2, 2, 1. Padding is the same. The depth input channels are 64 inputs, and the input shape will be 14 by 14 by 64. The depth output channels equals 64 outputs. The output shape A by 8 by 64 from this layer will have 64 channels. And from this layer, it will pass to the fully connected layers. The full collector layer 1 has the following shape. Inputs in channel, outputs out channel, and the size will be, the dimensions are 8 by 8 by 64 and 1024, which means that 1024 outputs will be generated from this layer and will go to the fully connected output layer number 2. And we see that we have an input of 1024 channels, and it will generate an output of 1024. The fully connected final output layer number 3 has a shape of inputs in channels, outputs out channels of 1024, and the outputs will be 10. Here we'll have an input of 10,024, but an output of 10. And each one will belong to each one of the categories that we mentioned before, such as cars, trucks, dogs, deer, and so on. After this, the output will be introduced to a softmax cross entropy to calculate the losses, and we'll feed the loss value to the optimizer to optimize the model and make it generate better results. We can see here the results of the building, training, and testing convolutional neural networks on CIFAR-10 dataset. We see that we used the TensorFlow to create the convolutional neural network. The accuracy resulted of this convolutional network on this step number 5000 was 68.73%. We're gonna talk more about the results in the next slide. The model was built to run 5000 steps in the training, and the testing ran every 100 steps to obtain the accuracy level of the convolutional neural network when predicting results for the CIFAR-10 dataset. We can observe that the accuracy level started at 42.88%, which is kind of low, but then it jumped to 48.29% in the step number 100. After the step 1000, the accuracy level started fluctuating between 60% and almost 70%. We can see that in the graph. The highest accuracy level is given at the 4,300 steps mark, and it is around 69.48%. In the last step, the accuracy level ended at 68.73%. From there, we can conclude that the maximum accuracy level for this dataset was around almost 70%. This is the second part of the project. We're going to compare the convolutional neural network performance between both datasets. As we can see here in this table, the MNS dataset starts with 15% accuracy, while the CIFAR-10 starts with only 8.77% accuracy. We see that after 100 steps, the MNIST dataset goes up to 93.99%, while the CIFAR-10 only goes up to 42.88%. At the end of it, when we are around the 5,000 steps, the MNIST dataset has 98.92% accuracy, while the CIFAR-10 dataset only reached 68.73% accuracy. Okay, now we're going to compare convolutional neural network performance in the MNIST data versus CIFAR-10 data. When comparing the accuracy levels on each dataset, we can see that there is a gap between MNIST and the CIFAR-10 dataset. Both have a similar behavior. The accuracy level starts low and makes a big jump in the first 100 steps. The MNIST dataset has a much more linear behavior after the first 100 steps, while the CIFAR dataset has more fluctuations, as we can see there in the graph. The accuracy level reached by the MNIST is 98.92% in the 5,000 steps, while for CIFAR-10 it is only 68.73%. We can observe that the gap is steady after the first 100 steps, and it's around 30% of the difference between the accuracy levels. In my view, one of the main reasons that could explain this gap is the fact that the MNIST dataset is a black and white images, and this contains handwritten numbers from 0 to 9, which might be easier for the model to recognize these patterns, while for the CIFAR-10, it contains color pictures of different things such as cars, cats, dogs, airplanes, deers, among others. This could make a difference for the convolutional neural network when extracting the features of the images. In my view, the second element that might be associated with the difference in the content of the images. As I was mentioned, the MNIST contains only 2D handwritten numbers from 0 to 9, while CIFAR-10 contains much more detailed images, such as planes, cars, and trucks, with all different backgrounds. Alright, in the following slides, we are gonna make a proposal to improve the convolutional neural network performance. Our proposal is the following. In order to improve the convolutional neural network performance, one proposal will be to increase the resolution of the images, for example, from 32 by 32 to 64 by 64. In this exercise, we're going to add one extra convolution layer. In this way, we will be able to extract more features from the images. I have decided to keep the number of steps the same at 5,000. In this slide, we can see our Jupyter notebook and how we created the third convolutional layer, the ReLU layer, and performed computation X by W added the P. We created the third polling layer and reduced the spatial size. We reshaped variant data, making it ready to be fed into the first convolutional layer. from the step number 0 to the 5,000. We can see that our accuracy level started in 0.1 and increased up to 65.6%. In this case, we had added one extra convolutional layer. After adding one extra layer, it was expected that with the third layer, the number of features extracted will increase to 128. We can observe that the accuracy level started at 10% and jumped to 33.91% in the first 100 steps. It keeps a tendency to increase with some fluctuation. In step number 3400, it drops the accuracy level to 59.25%. We can observe that the accuracy level ends at 65.6% in step 5000. One important conclusion here is that there is a small gap between the accuracy of the convolutional neural network with only 2 convolutional layers and the accuracy of the convolutional neural network with 3 convolutional layers. The convolutional neural network with 2 convolutional layers shows higher accuracy among all 5,000 steps. In conclusion, adding one extra layer here didn't show a big increase in the accuracy. It was actually the opposite. We have a little decrease in the accuracy of the convolutional neural network. Alright, here we have a summary. In the first section, the model was built to run 5,000 steps in the training and the testing ran every 100 steps. In that way, we obtained the accuracy of the convolutional neural network when predicting the results for the CIFAR-10 dataset. We observed that the accuracy level started at 42.88% and it was very low. And after that, it jumped to 48.29% in step number 100, I guess. After the step 1000, the accuracy started to fluctuate between 60 and almost 70%. In that period, we could see that the highest accuracy level was given at the 4,300 steps mark. It reached the accuracy of 69.48%. The highest accuracy level was given at the 40,300 steps mark, which was 69.48%. In the last step, the accuracy level ended at 68.73%. In the second part, we compared the accuracy levels of each dataset. There, we could see that there is a gap between both datasets, between the MNIST and the CIFAR-10 dataset. Both have a similar behavior in the sense that the accuracy level starts low, then it will make a big jump in the first 100 steps, and after that, after the 1000 steps, it will maintain a very steady behavior. In that sense, both are very similar. However, The MNIST has fewer fluctuations. MNIST reached an accuracy of 98.92%, while CIFAR-10 got an accuracy of 68.73%. In the last part, after adding one extra layer, which was the third convolutional layer, we saw that the accuracy level ended at 65.6% in the step 5000, which means that just adding one extra layer doesn't necessarily increase the accuracy level. After this, we are going to take a look at the conclusions. We have two main conclusions that will be discussed in the following slide. Alright, the conclusion. We have two main conclusions after creating a convolutional neural network and comparing that into a different data set and trying to increase the accuracy level. First of all, there is a gap in the accuracy of approximately 30% between the MNIST and the CIFAR-10 dataset. I believe that it might be explained by the difference between the complexity level of each dataset as well as the size and resolution. Lastly, adding an extra convolutional layer in the model does not imply that the accuracy will increase. As we observed in the last section of the project, the accuracy, instead of increasing, actually it decreased a little bit. So it is important to notice that only one action was not unique for increasing the accuracy level of the convolutional neural network. Thank you.